Okay, so this is just the last few sections of chapter 2. The lungs bring oxygen to the blood from outside air. And Boyle's law will describe how air comes into the lungs. We've talked about this. In fact, I think we had a question about this. Remember, Boyle's law says that the pressure times the volume is equal to a constant value. And so pressure and volume are inversely related. That is, if pressure goes down, volume goes up, and vice versa. So Boyle's law describes how air comes into the lungs. The lungs expand. Actually, the chest cavity expands. The lungs don't do anything. They just sit there. But when the chest cavity expands, that increases the volume of the lungs, and that decreases the pressure, so air rushes in. If V goes up, P goes down. The lungs are not muscles. They're really just sort of bags that are inside your chest. So instead, the muscles around the lungs will contract or relax to open or close the chest cavity, open it up or to make it smaller. Now the iron lung, we watched the video on the iron lung, and the iron lung is a cylinder, and people whose muscles have weakened and they're not able to expand or close their chest cavity as easily. Their muscle sort of around their chest cavity or their diaphragm is not as developed or is too weak to work properly. They go into an iron lung. And what the iron lung does is that the pressure inside of this canister will increase, giving you a higher pressure on the inside of the canister, and that leads to an exhale, or the pressure will decrease, and that helps the patient to inhale. So if you have a low pressure inside of the iron lung, then that will help the patient to inhale. It basically does the work of your diaphragm for you. All right. Let's look at the eye. Several things I want you to know about the eye. I'll probably give you a figure, something similar to this, or something like you've seen on the old test. And by the way, these additional things, I'll stick to sort of the basics, the basic identification. So I think it was a good idea for you to choose to do these extra things for the test. So the intraocular pressure, as the word implies, that is the pressure inside the eye. Intra is inside, pressure is pressure, and ocular means inside the eye. High pressure, there are two conditions. High pressure is glaucoma. If the pressure inside of the eye is too big, that's called glaucoma. If you have a low pressure inside of the eye, if your pressure is too low here, you can actually get a collapse of the eyeball. I dated a girl once in high school, and her mom had a glass eye, and I would go to her house, and her mom would just pop out her eye. Uh, so it was kind of cool. The cornea is the outer surface. It's labeled here. We'll talk about the cornea again in a later chapter, uh, but for now, all you need to know is the cornea is just this outer surface right here. The aqueous humor is replenished and drains. It is the fluid that is right here in between the cornea and the lens. So this is the aqueous humor. And this fluid will actually drain out and then it's replenished. The lens will focus light onto the retina. We have a whole chapter about light, and we will come back to the eye. It's really remarkable. It's my favorite organ of the body, or maybe the ear, I don't know. But this is the lens. And this is we'll talk more about it, but it's a variable object. Like it can change shape that will allow you to focus light from different distances onto the retina. The vitreous humor, this is remarkable. This holds the spherical shape of the eyeball. and it's not replenished. So this fluid inside of here is the vitreous humor, and it's never replenished. It helps to hold the spherical shape of the ball, but it's never replenished, or not appreciably replenished. Um, so the vitreous humor that you're born with, that's what you have pretty much your entire life. That's why babies are so cute, by the way. Babies are cute because their eyes look really big. They're too big for their face. I mean, if you think about it, they're kind of creepy looking. But their eyes are too big, and so they just, in our society, we say big eyes are cute. And uh, that's why their eyeballs are basically the same size of their whole life. The retina detects light. Talk about the retina later, but the retina is this surface back here on the back of the eyeball. Um, a tonometer is used to measure pressure in the eye. It measures the force required to bend the cornea. So if you've been to the eye doctor, they take this little tool, they hold it up to your eye, and it's like it blows a little puff of air onto your cornea. If you've ever been to the optometrist, they'll do this. And that's just to measure the pressure in the eye, in the aqueous humor. I'm going to show you a video, and I'll put the link down in the notes for this, of a tonometer that they use on a beagle. You don't need to watch it for the exam, but it's kind of interesting. It, has a dog in it, so where they use a tonometer to measure the pressure of the eye. The aqueous humor, oh, I'm sorry. No, that's right. That's the fluid between the cornea and the lens. That is replenished if the drainage is blocked. The pressure becomes too big, and this can damage the optic nerve. This is called glaucoma. So you know what glaucoma is, that it's a pressure that's too high. You can take medicines, or surgery can increase the drainage of the aqueous humor. Let's look at the brain. Several things I want you to know about with the brain. We're going to come back to the brain in a later chapter on electricity, but just for now, a couple of things about fluids. The skull includes the cranial and the facial bones. And the meninges. These are three membranes that cover the brain. And these contain CSF. CSF is cerebral spinal fluid. CSF, that acts to cushion the brain and regulates blood flow. Typically, we have about 150 milliliters of CSF in our brain and spinal cord. 150 milliliters. And 150 milliliters is approximately 3/4 of a cup. I'll put a video, you don't have to watch it, but it's kind of cool and creepy all at the same time, about the brain. Problems can occur with the production of CSF. Oh, you can get rid of this. Our lack of production. That is, that you can have not enough production. And this creates pressure in the cranium, and that's called intracranial pressure. Intra means in, cranial means cranium, or in the skull. So if you produce too much CSF, then you can have intracranial pressure. And so this abnormal accumulation of CSF in the brain is called hydrocephalus. It means that you have too much CSF inside of your head. You get too much swelling. And a lack of CSF can also cause problems. The brain can bump up against the cranial bones, which, as you can imagine, can be very, very painful and can cause long-lasting damage. Your brain, I've been told, I don't know this for sure, never seen a brain, but I've been told it's about the consistency of Jello, and so it sort of jiggles around inside of your head. But fortunately, we have these things to protect the brain. Okay, bladder. The bladder can hold about 500 milliliters or more of fluid. When it reaches about 200 milliliters, this is interesting, a person feels an urge to go because of nerve signals given to the brain at this pressure. So your bladder's not full, but when it gets to that point, it signals to your brain as like, "Hey, I gotta go right now." But if you wait, it'll eventually go away. But if you add another 200 or so milliliters, then the urge comes again, and then it's like, I gotta really go. This pressure for this urge, you don't have to know this number, but just to give you some feel, it's about 30 centimeters of H2O. This was another pressure measurement or unit that we saw. It is equivalent to about 22 milliliters or 22 millimeters of mercury. So notice that this column of mercury describing the pressure is a lot less than the column of water. Uh, it's not just 22 or 30. Notice the units are a lot different. That a centimeter is a lot bigger, 10 times as big as a millimeter. So this would really be 220 centimeters, or excuse me, this would really be 300 millimeters compared to 22 millimeters. Anyway, you don't need to know that number. I'm just sort of pointing it out. Pregnant women feel a greater urge to go. I'm told, never experienced this, because of outside pressure by the baby. The baby can kick into your bladder, but also just sort of having a baby in your stomach, I understand, can just exerts a constant force on your bladder. So this external pressure increases the pressure of the enclosed fluid in the bladder. And this is a great example of Pascal's principle. So if I have a bladder and I'm putting an outside force on it or an outside pressure, then that pressure is felt all throughout. And so your nervous system will send a signal to your brain saying, hey, I gotta go. All right, one more thing, we'll be done, is bones, stress and strain. We talked about this, but stress is a force per area, and strain is a deformation of a solid. As we saw in the physics section, stress causes strain. So that force per unit area will cause some deformation. And bone mass density measures the strength of the bone. This usually peaks in a person's 20s, and there are a couple of things you need to know about. Or there's one thing you need to know about. Osteoporosis, the bone density is reduced and made more susceptible to breakage. That breakage occurs when you exceed the elastic limit of the bone. Write that down. We saw that earlier, but if you apply a stress and it exceeds the elastic limit, then it will cause the bone to break. Okay, a few questions here. Tonometer is used to measure the pressure of the eye. Glaucoma is a high pressure in the aqueous humor. The aqueous humor, I always get these mixed up, but the aqueous humor is this pressure right here. Right, and so if I block the drainage here, then the pressure will go up. That's why the answer is not B, because the vitreous humor is right here, and the vitreous humor does not drain. The vitreous humor is there your entire life. That's why if you get those floaters in your eye, like they just sort of float around inside that vitreous humor fluid. The brain and central nervous system are protected by cerebral spinal fluid. A condition known as hydrocephalus is too much CSF. And then the part of the eye that is continuously replenished is the aqueous humor. Okay, I think that's all. Yep, that's it.